Good day, guys. We are going to continue from where we stopped in the previous video. We treated sampling distribution, and we were able to tell the relationships between population parameter and sample statistics based on the mean. Yes, based on the mean, we were able to deduce that the population mean is the same. Remember I gave them theorems, though they're not theorem per se, but just to make us know that they are like laws in statistics. They are just like laws in statistics. So the first one, I gave theorem 1. I said with replacement, if the samples are drawn with replacement, the population mean, which is mu, must be the same as the sample mean. And the same goes for without replacement, which is the theorem 2. For without replacement, the sample mean is still the same as the population mean. The population mean is still the same as the sample mean. That was where we stopped in the previous video. Now we are going to continue with variance. Let's try to relate the variance for the population and sample. Let's test if they are the same, just as the mean. Okay, starting with variance, we're going to start with variance, then we go to standard deviation. So starting with variance, that's still under the sampling distribution. So starting with the variance, let's take the population. Let's take the same population we used in the previous video, and let's sample with replacement this time around. Okay, we're sampling with replacement, picking the samples as you still remember: 1 1, 1 2, 1 3, 2 1, 2 2, 2 3, and you have 3 1, 3 2, 3 3. Okay, now let's get the variance for the population variance, and this is the notation. Remember I said variance is sigma square, so all you just need to do is put a mu underneath to tell that this is the variance for the population, or you call it population variance. Sorry for the spelling. Okay, remember the formula for finding variance. Since this is not grouped, you can just say summation x minus x bar squared all over n. And remember I said we can always, using table is not just for groups data. In order to keep your workings neat, you can use table even for groups. Okay, now we need to know the x bar, and remember x bar is the mean, and the mean for this is 2, if you remember from the previous video. Now x minus x bar, that's minus 1 0 1, and now x minus x bar square, that's 1 0 1, and summation of everything, summation of x minus x bar square equals what? 2. Okay, now divided by what? n. So variance, population variance equals what? 2 divided by 3. Remember n is 1 2 3. 2 divided by 3. Okay, now we've known the population variance, we need to get the sample variance. And remember, from the sample let me work it side by side here. Okay, now let's remember from the samples, if you're writing this out, okay, trying to adjust it. Now remember from the samples, finding the midpoint, you have 1 plus 1, that's 2. 2 divided by 2 is still 1, sorry. Then this one is 1.5. Then this one is 2. Then you have 1.5 again, that's 2 plus 1. Now 2 plus 2, 4 divided by, that's 2. This is 2.5. now this is still 2. This is 2.5, and this is 3. Now if you've noticed, we have just one, we have 2 of 1.5, we have 3 of 2, and like that. We can as well, since you have them occurring more than once, we can as well use table in order to make our work neat. You can as well use the table, which this is the x. Remember, x is, I'm just going to pick one of them each. 2, 2.5, then 3. And the frequency is, for 1 is just 1. You have 2 for this, you have 3, you have 2, and you have 1. Okay, now the fact that we've introduced frequency would make us use the formula for variance for grouped data, because frequency has appeared. Yes, frequency has appeared. Okay, so let's quickly remind ourselves variance for grouped data, which is what? Summation f x minus x bar squared all over summation of f. Yeah, you got it right. Okay, now, and if you didn't get it right, yeah, so that's a good way to quickly recollect. Yeah, now let's continue. We need to know x. We already know x. We need to know x bar, which is the mean. The mean is, you sum, remember, x bar from the mean. Calculating mean for grouped data is what? Summation of f times x all over summation of f. Yeah, so we need to know summation, we need to know f times x, because we need the summation of f times x. So f times x, this is 1. F times x, this is 3. F times x, this is 6. F times x, this is 5. And the f times x, this is 3. Okay, now if you sum everything, you should get 18. Yes, you should get 18. Okay, and if you sum frequencies here, you should get 9. So mean here is what? 18 divided by 9, which is 2. And I intentionally decided to go through this stress, yeah, just to remind us the formulas. But remember that from the previous theorems we've treated, your sample mean should be the same as your population mean if you've sampled with or without replacement. So I could have just written it here that the mean is 2. How did I know? Remember, the samples are just 1, the population 1, they're just 1, 2, and 3. If you find the mean of this, you get 2. So since you know that based on the theorem 1, the sample mean should be the same as population mean, then since I'm working with samples here and I want to get the mean, I should have just written 2. But then I decided to go through this so we can also remind ourselves what we've treated in the past. Okay, so yeah, now let's continue. We already have the mean. Now let's get x minus x bar, which is 1 minus 2, 1 minus 2, and that is minus 1. This is 1.5 1.5 minus 2, and that is minus 0.5. okay, that's 0. 2 minus 2, this is 0.5, and this is 2 minus 3 minus 2, 1. Now let's square them. Sorry for that. X minus x bar squared, this is 1, this is 0.25, this is 0, this is 0.25, and this is 1. okay, remember you have to multiply f times x minus x bar squared. So frequency, and that's 1. Frequency 2 times 0.5, that's 0.5. 3 times 0 is 0. 2 times 0.25 is 0.5, and 1 times 1 is 1. okay, so that is what 3 summation of fx minus x bar, that's 1 2 3. okay, we've gotten 3 there. Now we need to bring back the formula for calculating variance, which is what variance for the sample this time around. Remember, variance for population is mu, that differentiates it. okay, so bringing back the formula for variance, which is what summation f x minus x bar squared all over summation of f. Remember, summation of f minus x bar squared, which is what we have done here, is 3, and the summation of f here is the summation of the frequency, which is 9. So in the end we have 1 over 3. Now from the previous one, which is the population variance, we have 2 over 3, and so sample variance we have 1 over 3. Now the difference is just the population variance is 2 over 3, and the sample variance is 1 over 3. The difference is just this value on top here. Now in order to be able to relating these two would make us think a little bit deep. Now you would see that it is as if the sample variance, which is this, is the population variance but divided by 2. From this, if let's quickly work it out here, as 2 over 3 divided by 2. Now that's 2 over 3 divided by 2, which is same as what 2 over 3 times 1 over 2. This one cancels this. At the end of the day, you have 1 all over 3. So you can see that it is as if the sample variance is the population variance divided by 2. But where does this 2 come from? Is it the same for everything? Now if we treat another question, you would realize that this value underneath here is the same as the sample size. There isn't time to treat another question, that's why I'm not treating another question. But then this value underneath here would always be the sample size. Remember we said we should pick samples of 2 2 2 from the population. How many twos can you pick from the population? You have them here. So the sample size is actually the number of each of the sample chosen from population, not the total outcome, like 1 2 3 4 5 6 7 8 9. No, not the total number, no, but the sample size, the number of samples you pick at a go in the population. That is the sample size. Okay, it's very important that you note that. Very important, very important. So the sample size is that. Then we can then refine, we can then take theorem 3 to be what? The population, the sample variance the sample variance is the same as the population variance all over the sample size. And in notation form, the sample variance equals to the population variance all over the sample size, which is represented as small n. It's represented as small n. Okay, now I am going to go to standard deviation for with replacement, sampling with replacement, and the reason is because for without replacement there's just a little bit of difference, and I want to treat that together. So standard deviation, remember, standard deviation is simply square root of variance. Standard deviation in notation form is just this, equals to what? Square root of what? The variance, and which is actually in this notation is actually very reasonable. It's actually very reasonable, since this one can just cancel this one out and then it gives the standard deviation. Okay, that's just by the way. Actually. So standard deviation equals to square root of variance, and remember that we've already established that what? Sample variance equals to what? Population variance all over sample size. So in order for me to convert this, in order to convert it into standard deviation, what do I need to do? All I just need to do is put square root around it. So in terms of standard deviation for the sample is the same as standard deviation for the population all over square root of n. Remember that standard deviation is the square root of variance. So by the time we introduce the square root, in order to convert it to standard deviation, x cancels 2 square cancels the root. Square cancels the root that covers only this, not everything. Because remember, sword, you can change it to this, still the same thing as what we already have. So this one cuts only that. Then you have standard deviation for the sample equals to the standard deviation for the population all over square root of the sample size. Okay, that is for with replacement when considering relationship between samples and population. That's with replacement. So let's take the theorem again, what I termed as theorem. Now theorem 3 or so, sorry, yes, the third theorem is what? I'm trying to review the theorem. The third theorem is the sample variance equals to population variance all over what? Sample size. And the fourth one, which we just finished up, is what? The sample standard deviation equals to the population standard deviation all over square root of what? Sample size, provided you have sampled with replacement. Provided you've sampled with replacement. Okay, the following video would treat in the following video. We're going to treat questions on this particular aspect of the lecture.